Everyone, and welcome to another SuncatByte. In today's SuncatByte, we are going to cover escape sequences and IOmanip, which are both output-related topics that are related to outputting stuff to the screen. So for escape sequences, I want to look at this chart. So basically what an escape sequence is it's a special character. It's this character, which tells us to do something special with the output. So far, the escape sequence that we've actually seen is this new line escape sequence here. So if we do a /n, that's going to give us a new line. Some other things that we can do is say we want to see an actual backslash in the output. I'm sorry, a backslash. Backslash and here for the new line. If we want to see a backslash in the output, then we do backslash. Backslash double quote will give us a double quote. Backslash single quote will actually give us the single quote in the output. So we'll see an example of this shortly, but this is called an escape sequence, and that character, that backslash character, is known as the escape character. So now, IOmanip. What's IOmanip? IOmanip is a library that's used to manipulate the output stream. And one of the manipulators that's in that library is called setWidth, or setW. And this sets the field width for the variable output that follows. So if we have setW5, that's going to reserve 5 spaces to write the value of the following, of the variable that follows. So something like this. Cout. There's our new line, escape new line character. The value of x is, and now we have this setWidth 5 x. So what that basically means is that it's going to save 5 spaces for the output of x, and it's also going to be right justified by default. So keep in mind that setWidth is right justified. We'll see some more examples of setWidth here in a bit in the examples. But some of the other IOmanip manipulators that we can see are listed in this table here. So you can output stuff in decimal format by using DEC, hex format by using hex. You can justify things left and right. You can do scientific notation by using scientific. If you do show point, that shows a decimal point, and trailing zeros for all floating point values. If you do that in conjunction with fixed, then you get the decimal point and the fixed value. And if you use precision, so you have precision, fixed, and show point. If you use those three in conjunction, then the precision will actually show you what the decimal point, or show you the number of decimals after. So precision is also used here. And we'll see an example of precision here also. So let's actually take a look at a couple of examples. This table is also in your book and in the PowerPoint slide, so you can look at it there as well. But let's look at a couple of examples. So let's look at program. First one I look at is just the one for escape sequences, which is program 218. So if you can see here in this program, Let's zoom in some. Whoa. There we go. So you can see this is an example using escape sequences. So we have IOStream for cout. We have your using namespace standard. This is, of course, a preprocessor directive. We have int main, and then we have our cout statement. How are you liking C++ programming today, second edition? The /n characters escape sequence for a new line. So let's see what we actually get when we do this. What happens? Let's build the solution. Let's start without debugging. And here's what we get. So notice there's a blank line here at the top. That's because we have this new line character here, so we get that blank line. Then we have this line here, how are you liking? Like we have there, how are you liking? There's a space, and then another space. So there's a space here, so we see two spaces up there. Then we see a backslash double quote. So that actually gives us this double quote character here. So backslash and then double quote. So that's double quote C++ programming today, second edition. Then we have another backslash double quote here in our code, which gives us this double quote here, space question mark. So that escape character escapes that double quote character. And then we have a new line here. So that's why we go to the new line there. And then backslash n. So the backslash gives us this backslash here. So it says the backslash n is an escape sequence for a new line. And then we have the actual new line there. And then we're done. So go ahead and go through this example yourself, and you can see how the escape sequences work, but this is just one example of using escape sequences in your output. You can also take some of the ones in the table and play with those, see how those work as well. All right, so that would be 218. Now let's look at a couple of the manipulation flags from IOmanip. Let's start with 219. All right, so here, notice we include the IOmanip library, and that's not just for nline, it's also for some of the other stuff we use in here. Then we have some variables that we set, double pi equals 3.14159, so on and so forth. If we didn't want these variables to change, we could use the const keyword, which we learned in another SuncatByte. Okay, so first things first, we're just gonna write the values out. We haven't set any flags at all. So we'll see what values we get for pi, feet, and number when we do that. Next, we're going to set the precision to 5. Okay? When we do that, it fixes how many spaces are used to write the values. So we should only have 5 spaces. Now, if we use show point, that's going to go ahead and show the decimal point, but our precision is still 5. Now, if we set the fixed flag along with that, then that's going to give us 5 decimal places. So, and the combination is actually of precision, fixed show point. So let's go ahead and build and debug. Start without debugging. Here we go. So without setting any of the flags, we're going to get the output here at the top, which is just first write, not setting any flags, right? Now, when we set the precision to 5, but we set the precision to 5 and no show point, right? Let's see here. Sorry, so down here. Precision to 5, it's this output. This is what we're looking at next. This is going to be what's in the middle. Set your precision to 5, and you have a show point. You see a decimal point, but there's just 5 digits. The precision is 5. You don't actually get 5 decimals, right? Now, if we then set the fixed flag, which we do here, then we get the 5 decimals, 3.14159. That's 5, 5, 5. Okay, so that's the 3 different ways you would use those flags there, and the varying results you'll get. Okay, one more example. 220. 220 is a little bit similar to the other one. It does have the set precision and the fixed to give us the 5 decimals, but it also does some things with set width. So we're including IOmanip again. This is the same, setting those variables and initializing them. Here is just a precision of 5, so we should get five digits. Here we have fixed and precision, so this should give us the 5 decimal digits. Here. Now we have set width. Remember in the notes we said set width is right justified, so now we'll have set width right justified here. So this will give us 12 spaces for all of these variables. So basically what it does is it lines them up right justified and then gives us 12 spaces for the output. And then now this does the output in scientific notation. In order to use scientific notation, you have to unset this flag. Something that's also, and then you set the flag here. Something that's a little bit different here is you notice that these are set inline. So you can actually just use the set precision inline here inside of your cout with the insertion operator, and you can set your other flags this way. If you go back and look at 219, they're actually set in statements before the output statement. So you can do it two ways. You can do it in this mechanism in 220, which is inline, or you can do it before, which is done in 219. All right, so let's go ahead and build this. And let's run it. Start without debugging. Here we go. So this output at the top is just five numbers of precision. 5280 only had 4, so we only see the 4 there, right? Now we set it with fixed precision. So having the precision and fixed set, you get the 5 decimals. That would be this code here. So now we're going to go a little bit further and see the set width. Here with the set width, notice this is actually, if you look here, there's 12 spaces there. 12 for all of that output. So to output pi, feet, and number, because they all have a set width of 12, and it lines them up right justified. Now if we come down here, unset the fixed, and you do it in scientific notation, also a set width of 12, so again, right justified, and we get the scientific notation. So there's some examples on how you can manipulate your output. If you wanted to use 2 decimal precision, like we will do in probably many of our programs, then you're going to use a combination of precision 2 and the fixed flag. Well, that's all we have for this SuncatByte. If you have any questions, as always, you can email me or post on the discussion board forum or attend office or lab hours. Talk to you soon. Bye.